Okay, so just a quick little reminder, there are two different equations we can use to calculate the formal charge of a particular atom, and they both end up with the same result. So the first option, you're taking the number of valence electrons for that particular atom, you're subtracting the number of lone pair electrons, so the number of electrons that we display as dots, minus 1/2 of the electrons that are involved in forming bonds. Or the formula I actually prefer, I think it's a little easier just to remember, is valence electrons minus the number of dots minus the number of lines. Either way, you will get the same answer. It's just a matter of personal preference. So let's go ahead and try this with an example. Okay, so here I have two different Lewis structures of hydrogen cyanide. And what we want to do is determine which is the best Lewis dot structure based upon the formal charge. So for these, they all have the correct number of valence electrons. They all follow the total number of electrons. We just want to see which one's the best option. So I'm going to go ahead and get started. So for this first one, for the hydrogen, remember there are the two formulas we can use. I'm going to use the second one. So we're going to take the number of valence electrons for a hydrogen atom, which is 1. We're going to subtract from that the number of dots, which in this case, there are no dots on hydrogen. So we subtract 0. And we subtract from that the number of lines that are connected to that hydrogen, which in this case is 1. So 1 minus 0 minus 1 gives me a formal charge of 0 for that particular hydrogen in that structure. Now, for my carbon atom, carbon has 4 valence electrons. In this case, it has no dots on it, so I subtract 0. And I'm going to subtract the number of lines. So I have 1 line on this side plus 1, 2, 3 on this side, so that's a total of 4. So 4 minus 4 gives me a formal charge of 0 for this structure. And then finally, for my nitrogen, I know that nitrogen has 5 valence electrons. I'm going to subtract the number of dots, which in this case is 2. And then I'm going to subtract the number of lines, which if we count, we have 1, 2, 3 lines coming off of the nitrogen. So 5 minus 2 minus 3 gives me a formal charge of 0. So overall, I already know that this is looking like a very good Lewis dot structure because all of my formal charges are 0. Ideally, I want those to be 0 or as small as possible. But let's go ahead and try out the other Lewis dot structure. So for my hydrogen, again, I have 1 valence electron. I'm going to subtract the number of dots, which is 0, and subtract the number of lines, which is 1. So that gives me a formal charge of 0. So again, we're still looking pretty good. Let's try the nitrogen now. So nitrogen has 5 valence electrons. We subtract the number of dots, which is 0, and we need to subtract the number of lines, which in this case is 4. So 1, 2, 3, 4. So that gives me a formal charge of positive 1, which is not great. Now, if we go ahead and look at this carbon, let's go ahead and calculate its formal charge. So valence electrons for carbon is 4, minus the number of dots, which is 2, minus the number of lines, which is 3. So 4 minus 2 minus 3 gives me negative 1. So I don't have huge formal charges here, but it's not ideal. This one is really the better option because they are all 0. Now, if I'm ever comparing options and I don't have an option that's all 0, I want the negative formal charge to be on the most electronegative element. So again, something else to consider here, it's not. So again, this is really my best Lewis dot structure, and that's the one that I put down as my answer.